Alright, back on this 92, what is this thing, softail I think, originally? Yeah, whatever that means. Look it up. Alright, let's see, I got the cylinders done last night. So that's what they look like, all cleaned up. I'm going to work on the lower end today, so we don't need the pistons anymore. And next week we get to work on the heads. Let's see, this here I got to put new bearings in it. They already been all cleaned up, flushed and banged and everything else you do to them. These early cases are pretty weak. Common as they're picking me when reusing the stock cylinder studs. The way I look at it, these stock studs have been in there for 30 years, almost 25 years, and they're still good. Why screw with them? The problem is the cases. Now, if you look at the cases, you can see all the porosity in the case. That's all these holes right here. And see on this side over here, you don't see as much of it. So Harley had a lot of problem with the cases where they pull the ears off of them. The ear being like the whole top of the case here would come off, the whole center here would come off, the back corner over here would come off. It would just pull right off the case. Especially if you over-torque your studs or you put real high compression motor together, have a lot of detonation, you really have problems. So these are very weak cases. These cases are still good, so I'm not going to change out something that's not a problem. I don't just replace parts for the hell of it. We were going to put all these parts new in here though, so all that stuff's got to go in here. They also have really crappy cranks for that year, so we're going to put an ultimate crank in it. Now last time we took an S&S crank apart and it was 7/10 out around on the big end, and it was 1 to 2 thou clearance instead of being 9/10 to 12/10, which is only 1 thou. So we're going to take that apart and see what it looks like. First thing I do is get these out of the way so we don't bang into them. Frees up a little bit of space on the workbench too. Space is limited around here. Okay. Get it out of the way. Now I got some room to work. Okay, so what's the verdict on how good these are going to be? Let me know. We know how crappy the S&S is. Yeah, nice already dull again, look at that. Yeah, nice sharp knife. I sharpened that yesterday. Yeah, they come well packed. Oh, there's a crank in there. Yeah. So I do my exercise in the morning. Can you pick up a 50-pound crank with your arm? Yeah. Alright, one box out of the way. Workbench got dirty. Look at that. Dingleberries. One thing I don't like about them is H-beam rods. They hurt when you pick them up with a rod. I-beams don't hurt you when you pick them up. That's very important. Stand on a rag while you're picking it up. So crap falling off of it. Okay. Got clearance, I like that. Good inflate, that's a good thing. Doesn't feel like there's any oil in it though. Crank's not rusty yet. That's a good sign. Is that an Evo pin or a Chevrolet pin? I can't remember. Who knows? The only pin that really matters though is the one in the piston kit. That's the only one that really matters. So I gotta take this out of the piston kit over here. Yeah, one wrist pin. Those are shovel pins. That's why they were loose. Slides in real nice and easy, but you don't feel any clearance in it. That's good. That's a precision check. If it feels good, run it. If it don't feel good, don't. It's a real test. Alright, so now we're going to take this thing apart. See how bad it is. To be tight. Yep. Alright, those are tighter than this nest because this nest will come off. It's already starting to round the nut off a little bit. Alright, we got to get more serious about this. I have to use a big breaker bar to pull this out. Okay, this is the part that hurts my hand. See, I'm picking up by the rods again. Alright, we'll come over here. Okay, we're not tightening, we're loosening. This other direction. Okay. And that's already starting to round off a little bit. That's a problem. Have to work around that problem. Trying to space the socket just right over here. But you can't see a damn thing from that side. So we gotta put the socket on the nut like that. And put a spacer underneath that. See, that doesn't fit under there. It's because the press is too much. a little bit. Put pressure on it. Okay, now that is under it, so it won't twist off. You're just torquing it down now. So we got our breaker bar ratchet here. There. Now I just need a long handle for it. Of course, our handle is the press handle right here. See, there's the handle for the breaker bar. Precision made. Now just put a little pressure on it. That Loctite's definitely biting pretty hard. That's why I don't use sleeve retainer Loctite on my nuts, because you don't need to. That just makes them hard to get apart. Doesn't make them any tighter, doesn't keep them any tighter. It makes it harder to get apart, that's all it does. Alright, socket, ratchet, place for that, and handle. Oh, testing out my snap-on universal ratchet head. They come in handy. All right. Take this thing apart. See if it'll come apart. That's the next problem. So you can see the Loctite coming out of the nut right there. So you see how it tears out. So the next problem is, will the crank actually come apart? Or we got to come back over here and beat the hell out of it again. Okay, more workout and make my thumb and fingers sore. See, that's hard on my thumb, see. I don't like H-beam rods. They hurt too much. That's the problem with H-beam rods. Okay. Few nut jams in there. Oh, flywheel fell right apart. See, S&S's, they don't come apart like that. These nuts don't come apart either. There we go. So they Loctite the hell out of the nut. Didn't do much for that. Appears that's red Loctite. See, you tell it's red? Because it's got residue on there, red. Red. So, I'm not sure why this thing fell apart so easy. If that's got red Loctite right up on the edge there, we don't want it, or what? I'm not sure. They got a real smooth surface there. You can see where the crank pin was pulling against the surface pretty even, but it didn't bite very hard. Which tells me there's probably a difference in angle between the two. So the S&S's, they hold really, really tight. With the nut off the thing, it's all you can to break them apart, which I like a lot better. That's also why I use sleeve retainer Loctite on them, on the tapers, not the nut. But obviously it torqued the piss out of the nut because it wouldn't come off. So they did put it together really nice. That was good. Alright. Let's see what we got here. There's the extent of the lubricant they put in the rod bearings. Basically nothing. roller fill out. It's just basically dry. So that means you better have oil pressure before you start running this motor, because there's a lack of pre-lubricant in there. Not much. That's bad. They run a pretty coarse finish on their hone here also. See how rough the crosshatch is in that? Hear that? That really is going to really loosen up as it breaks in. That's bad. I don't like having it. I have a nice smooth finish, so there is no break in. It's broken in as soon as you start running it. That's how you want it to be. When they're really rough like this, things move a lot. Yeah, that's pea gravel. That's really coarse finish. Makes it quicker doing the job. Okay, so it appears they had just a little bit of something on the crank pin there. Not much. Some kind of a grease. I don't know whose crank pins they're using now. They used to use Jim's products, but they don't use them anymore. But see, that's a nice smooth finish on that. That's what the other side of the bearing surface should be, which would be the rod. Having a real coarse finish like this and a real fine finish doesn't make sense. Okay, so I'm going to measure the diameter of the crank pin here. See what we come up with. Appears to be way undersized, which is normal. They build the clearance into the crank pin. Looks like we're about 2/10 down. Yep. Yep. So it's straight. About round. Yep, 2/10. Yep. It's within 1/2 tenth. That's good. There's a big mark in that. What they did that for. Got a big notch in the top of the flywheel for some reason. Probably some kind of an identification thing. It's only on the one wheel. Either they dropped it. Which one do you think it is? Take your pick. Alright, looks like they're still using Jim's nuts. I like all the foam inside the oil gallery. That's pretty nice. That's an extra cost item. So they're using a Jim's nut. The shaft doesn't say Jim's on it though. The nut is. I don't know who made the shaft. It looks like it might be a Jim shaft, but usually they're marked on the end of the shaft with the Jim's. So I'm going to guess not. And I'm going to get on this side. This one's not marked. Brand X. Alright. So we measured the rod. Not the rod. Crank pin. Crank pin's 8/10 under. So if you set the rod at standard, you got 8/10 clearance. So I'd like 9 to 12/10, which is 1.2 thou on the high side. Okay, now we're going to measure our bearings here to see what size the rollers are. 1/10 under. It's pretty much the norm anymore. That one's almost 2 under. Yeah. About 2/10 under. Seems to be this new standard. Whatever's on the bearing size package, take 2/10 off. That was 1. That one's 2. 2. Always measure each set of bearings because they might have got this loaded out of a different batch of rollers, you never know. 3. It says consistent 2/10 under that, so the bearing's pretty much 2/10 under. So if you take 2 and 2 and add them together, you get 4. You figure 1's error, so you take only 3. You add that to your 8, you get 11. So that's 11/10 clearance if these are on standard size. It's called math. Okay, so this sets my bearing checking gauge. So I'm going to take this over here to our rod hone. Right there in that gauge right there. We'll go ahead and set that thing. See what we got. Kind of stabilize. Gauge is slow reacting. But it comes in at 0. See the 0 up there? I don't know if you can see the 0 or not. If you get up there, you might see it. There's a 0 right there. Okay, now you take your rod, this thing here, stick it on there and see what number we come up with. Okay, we're 1/10 under. 4/10 under. 1/10, 4/10. That means you're 3/10 out around on the rod, which is not exactly on the standard I like working to usually. It's consistent though. So it's 3/10 out around. Not tapered though, but 3/10 out around. Definite quality piece there. Well, that's half the tolerance of S&S. They were 7/10. Okay, so that one we're at 0 and 2/10 down. That 2/10 out around, that's a lot better. Okay, that one's 2/10 to begin with and goes down to 3. Alright, so that one's got a little taper to it. Alright, so there you go. So you got 4/10 as our lowest number. You add that to the 11 we had, that's 1.5, 15/10. That's on the bad side. On the good side, it was 4/10 better than that. 11/10. So they're size loose, which is okay for hot rod use. But for a high mileage motor, not quite where I want it. And the bearing surface is really rough, so I don't like that either. So I'm going to have to hone these and square them up a little bit. I got to find some rollers to use. That's always fun. Okay, so those are supposedly standard, which are 2 under. Standard's not going to help us because we need to go bigger. Okay, let's do some rod rollers. These are rod rollers. These are, what year rollers? Late or early? Doesn't say. Ah, there it is. It says over there, early. Wrong package. Yeah, late. There you go, late. Late being aluminum cage, not steel cage. Okay, here's some 2s, here's some 4s. 2s and 4s. So we're going to be in this group of boxes right here. Out of the way. Alright, so now we get to figure out what we got for bearing rollers. See what we got to work with. No use holding the rods if you can't hone them to something you already own. Alright. So that one says 1 under. That says rusty. Just because they're new don't mean they don't come in unrusty. So these have rust pits in them in places. Not recommended these get used. They're okay for a race bike because I don't run them long enough to matter, but unless I'm going to run on a street bike. Okay, so these are 2/10. 2/10 could be 2/10 or 2/10 could be standard. Depends on who made the packaging. In this case, 2/10 is standard. Standard is 5/10 on the mic here. So you got a 5. When that line lines up with a 5, it's 5/10. So 2/10 is actually standard. Because 3/16 is 187.5, not 187.3. So I'm going to jump right over the 4/10. Trying to get away. Piggy was trying to make a run for it there. Okay, now what number we got on these ones? These are 7/10. So 4/10 is 2/10. Yep. That's what these are. That one's actually 8. A little extra. Okay, so stay over there. So let's see. So we're using 2/10 out and the 4/10. 4/10. Might be enough in there. So you put them in 2 plastic bags because each bag has holes in it. Alright, let's see what size this one is. This one is 7/10 to 8, between 7 and 8/10. So these are the correct ones. Okay. So 4/10 is actually 2/10. Nothing like being consistent. Let's grab a couple more of those just to make sure. And right now we're about 1/10 over too, so we're actually an extra 1/10 over. Seems to be consistently at 8, which is 3/10 over. Yeah, so we're going to figure 3/10 over. That gives us 6/10 more. Alright. Alright, so now we got 6/10. Crank pin was 8 under. Bearings are 3 all over each side, which makes 6. 6 and 8 minus 8 plus 6 makes -2. Getting any of that? So -2 on the gauge here is what our -2. That is the what the hard number is. Now you want your clearance added to it, which is going to be 9/10 to 1 thou. So if you figure it's 1 thou, that'll put you down here at 8/10 here. So we want somewhere between 7 and 8/10 on the gauge. Right now 4 is our loosest point. So I could try honing that for 4 and it'll come out close. Maybe, but we got this rough ass finish on these rods. I want to get it out. So we're going to shoot for that 7 to 8/10. We're going to call it 8/10 and we go plus or minus 1 on that if we have to. But I prefer using the number I come up with. I want 8. That's the number I want. Get this camera out of the way. Alright, so now we're going to go ahead and hone the rod out for 8/10. So, brand new crank we get to rebuild, just like we had to rebuild the S&S crank. Nothing like being consistent. New parts need to be rebuilt. Okay. dump it in the goo. Yeah, goo on it. Alright, we need a little bit of light over here. There, light. Lights up the place. So that works. Okay. Something I should do, which I haven't done yet. So I get my hands all dirty. I need to go check these rods, see if they're straight. Let's go do that. We know it's going to be perfectly straight. Everything else is good, right? That light switch. All right, down here are the rods. Actually, it's on the wrong side. I don't like working on that side. I like working on this side. Okay, rod lining tool, or actually rod checking tool, and the lining tool. All right. Okay, I'm going to check this to see how straight it is. Box of crap my way. I can't walk around here with crap my way. There, I can walk in here now. Amazing how that works. Okay. Eagle wrist pin. Got a little doggy here. It looks like a dog. No tail though. So these three little fingers that stick out here need to be flat against the plate. If you're like this, the rod's bent that way. If you get twisted like this, the rod's got a twist in it. If you got a combination like that, then it's twisted and bent. Pretty straightforward. You can rotate it too like this to make sure it stays the same. Appears to be good. Yep. So here's what we're looking for. Look for the gaps right in between here. So, can you see the gap? You rotate it, there's no other gaps, see? Now I'm not pushing on, I'm laying on top of the wrist pin right here. Just letting the weight of the tool do it. So if you see no gap in between like there, you're good. That's probably way out of focus, and, oh well, but you get the idea. Simple tool, very effective. Okay, that one's good. Usually if one is good, both are good. But not always. That's why you check them both. Never take anything for granted. That one's got a little bit of a gap right there in that corner. Flip it around and check it again. See if that's me or the rod. Plus I got the other side now. Got the same spot. A little bit of gap on the top also. So it needs to go up. Needs to be a little twist in it, and goes up. The problem with the H-beam rods, they're really thin, so the tool wants to collapse the rod. That's why I made this tool. It's extra long to get in there. Doesn't do it. So you want to see how flexible rods are, H-beams? That's the problem with an H-beam rod, they're pretty flexible. So look how much flux you get in these things, see? See how it fluxes? Quite a bit. So I'm not putting much pressure here. They're really strong side to side, see, like this. I'm going up and down right now. But the twist is real bad. There's no strength in them at all. I-beam rods are a lot stronger in both planes. That's what I like about I-beams over H-beams. Everybody says H-beams are stronger. They're only stronger because they're made out of better material, not because of better design. They make strong I-beam rods too. Just a tip too far. Just gonna wiggle it a little bit, that's all you gotta do. Everything has a little bit of a memory to it. Yep. Memory wasn't good enough. Bend it a little bit more. You go back and forth on it to kind of get it to kind of neutralize. You're trying to see what the new memory is, not the old memory. Looks pretty good that way. Take it out, turn it 180, put it back in. And you're looking to make sure the gap is equal on both, all the way. You want to make sure it repeats. That means you turn 180 and check it. If it's still straight both ways, you know you're good. If you get a difference, either your tool is bad or something else is wrong. But anyway, you can see how now there's no gap on the tool in there. It is now straight. You can rotate it like that if you want. Try different angles. Stays against what you want. Like so, you're trying to just use the weight of the tool, not you putting any pressure on it, because you can actually press against the wall and lift up in the back of the tail here, so you can cheat and fool yourself maybe if you're stupid. Okay, so that rod's straight. It had a little tweak to it. It's now untweaked. Now we can go ahead and hone the big end. Get it squared up. Now just bending the rod around here does affect the big end on roundness and all that. That's why you want to do it before you do all your honing, not after. I found that out one day when I checked one after I honed it. I was shocked on how far out around it was. Everything has a memory, so it wants to go back to wherever it started from. Okay, you cover that up so you don't bang yourself. It hurts when you hit this into your hip because this doesn't move. You also want to cover it up so the moisture does not make it rust. That's kind of important too. Get in there. That's all messed up. Yeah, work on it later. It'll work until the next time I take it off. That's it. Now we get to go back to the hone. We got honing to do. So you lay out your shop, you make sure you got access to all your points. You have to walk around 15 different ways. It's amazing how many miles you walk a day in a shop trying to get work done. Okay, now we're going to hone these till we get. That's called preparation work there. Okay, we got 3 different stones to use. First one is a real coarse one, which is probably what they were using. Then we go to a medium grit stone, and then we go to the ultra fine stone. So the difference in finish, you might be able to tell the difference there. So usually what I do is I go to the coarse one right off the bat. It knocks the rod it gets it pretty straight pretty quickly because it takes off the high spot pretty hard, which is what we're trying to do. You want to knock that out of roundness out there as soon as you can. pressure on it. Okay. Oil where it matters. Swipes each way. So there's my course finish, and it's a little bit finer than what theirs was, I think. But close. I go over here. What we got 3/10, 7/10. Not coming up very good. Okay, this side here is 4, that's 5. So we got that one side out. The rod has a little spot on one side. That could have happened when we were bending it. So, yeah. When you take a brand new rod and a brand new race and move them around a little bit, the press fit bushing might give you a center point in the rod where it's more happy. It'll go to that point at some point, but it's better to do it now. That way when you're running the motor it doesn't change on you. So we developed a little bit of a low spot. Yeah, this one is 6 there, and it's about 6 in there now. That came pretty quickly. That's 4, bounce to 6, and it's back to 5. That's 2/10 out. So this is the worst one right now. Okay, so we're getting close to what we want. Let's see, we're at 6 right now. We want 8. Okay, I'm going to go ahead and switch my stone to the... Actually, I'm going to... This is our worst rod right now. What number are we at on this one? I'm going to hone this a few strikes by itself. Try to get it come in. Five to 7. 5 to 6. That's going to quit now. The rods don't hone equally when you get them assembled. The center rod never cuts as much as the outer rod. It's just how it works. You would think it'd be even, but it's not. Okay, just our intermediate grit. A few swipes on this to see what we get. Taper in this rod, so I gotta figure out which side is which here. This side's the tight side. So we've only got about 1/10 to go on these, 1/10 to 2. Okay, we've got to cool these off. You can lower the cool tank, so them cool off a little bit. Then we switch over to our fine stone. So we only got 1 or 2 tenths to work with left. So we'll have a lot of material. We used up most of it getting it round to getting the coarseness out of the finish. The heat will expand these by 1 or 2 tenths, so you always have to keep them cool. Everything has to be at the same temperature, whatever that is. It's a lot easier to keep it at room temperature than an elevated number, so that's what I do. Pressure. Got a temperature to take out, but it still doesn't cut hardly anything. It's a real fine finish. I'll use the big rod to see it better. Trying to get the oil out. So see how fine of a finish it is in there? Real fine. Okay, what do we got now? 7 to 8. 7 to 8. About 1/10 under that. I mean, 10 millionths. 1/10 of a tenth. Okay, this one is 7.5 to 8.25. That's tenths. This one's just under 8, just over 8. So this side needs to get on, this side's good. It always cuts more on this side than this side. Always. Pull it off. Shrinks that 1/4 of a tenth. You can't see what I'm doing on the rod up there. I'm measuring 7.5 to 8.5. 7. This one, 7 to 8, 7 to 7.75. Feel the rod, you feel room temperature of heat. Still 7 to 8. Still 7 to 8. Good change. About 8 3/4 now. That tenth doesn't want to come out of it. The tenth seems to want to stay in there. I'm happy though with a tenth of accuracy. Well, that was 4/10 out to begin with. The other rod was out 2 on one side, 3 on the other. In case you're not sure what a tenth is is when you take a 1/1000th and divide it by 10 ways, that's what a tenth is. It's not a tenth of an inch. That'd be huge. Okay, I'm going to put the dial over here so you can kind of see what the dimensions are. So you can see the dial up there. There should be a good view right there. Okay, so there's our finish right now. See how smooth it is in there. Oop. Nice and smooth. See, no more thumb noise when you go up and down on it. Okay, we're looking for 8. So there's just a tick under 8. And 8 5/8. 7 3/4. 8 3/4. 1/10 out. So we got with 1/10 on that one. That's not one to come out for some reason. Okay, this one here, we're at 8 right there, and about 3/4. This one here, 8, about 3/4 again. So this one's about a 3/4 of a 10th out. That'd be 75 millionths of an inch. 6 digits. Sounds impressive, but it's only a 1/3 of a 10th. I look at it that way. Alright, so there is how you do that. And so now we got these a lot closer than we started with. And now we need to go clean these up so that we can put this together. Alright, we'll be back.